Hi, and thanks for tuning in to the CBA Podcast, a place where we chat about our own recent achievements in the area of electronics, software and mechanical engineering, and more likely than not, give excuses for not having done anything at all. Hello, and welcome back to a new episode. I think after 25 or so solo episodes, we finally have a co-hosted episode again, and this time Domen was so friendly to lend me a hand, to talk a little bit about what he did. He's a guy known for, I think 10 years, maybe a little bit more. I guess a bit more. And we share interests, for example, low-level electronics, low-level software, getting to know how stuff works, finding out, digging down to the root of something to find out how stuff works. And nature, I guess, some science. He's a fairly friendly guy, I can get along with him quite well. And I actually have to say stuff like this because he's probably listening. Hello. Recently he has been toying a little bit with Rust programming language. I never did anything with it, but he did. I think he comes from a C background that does a lot of C, did a lot of C, so now he's toying with Rust a little bit. So we'll talk about that in a moment. And after that we'll also talk a little bit about coroutines, which are a cooperative mechanism for having very lightweight tasks in your C code or assembly code. So let's listen to that a little bit.
Yeah, I don't have anything prepared really, but
okay.
Rust is awesome. I just
okay.
Actually, just when was that? A few days ago, I kind of used a few Rust projects just to try them on the board, just to see if it works.
Oh, right. Yeah, that was a LED blinky, right?
Yeah, it was like 8 LEDs blinking, so that was.
That wasn't interpreted or something like that, right? Do you have a?
No, it's compiled in.
No, it's compiled.
It's like C.
Right.
Pretty much.
But it was
like
quite.
C.
Yeah, but it was quite big. You said. Like you didn't look into it probably, but is it using a lot of, including default libraries or something like that, or startup code or memory management? I don't know.
There is some of that code, but the thing, maybe I still have that opened, because I had some project and I was like surprised. Why is this? I don't know. I'm making up numbers now. Why is it 2 kilobytes just for 8 LEDs blinking? And then I look into assembly and I see they unruled a loop.
Oh, right.
I mean, the compiler was smart, optimizing for speed.
Optimize for speed, yeah.
Yeah, so then I changed optimization to size, and then it was 1 kilobyte less, so that was nice.
Okay. And what compile did you use again? You told me, but I forgot, I think.
For Rust, it's just Rust C, like Rust compiler.
Okay. Does it?
For the backend, I mean, that's just the intermediate. I don't know, how do you call it? It's not assembly, but similar to assembly.
Yeah, okay. But
and
it's
then
not...
it's LLVM then takes over to get into machine code.
What is that?
Oof. Yeah, you know GCC, but like the competitor is Clang and LLVM.
Oh, yeah. Oh, that LLVM I don't know.
So, I mean, it's part of the same thing, really. It's just that one gets you from C to intermediate representation, the other gets you to machine code.
Okay.
So it's done in 2 stages.
Yeah. It doesn't compile to C first, right? No.
No.
So you have something lower level than C, and then from that you go to assembly. Is that right?
Yeah.
Okay, and that intermediate language, let's call it that. I don't know what it's called, but is it Rust specific, or do you?
No, that's LLVM specific.
Right, so you can get from multiple higher level languages. You have compilers on multiple higher level language to that language, and then probably you have like lower level compilers or assemblers to target a specific chip.
Yeah.
That's how it is. Okay,
that's the idea. Yeah.
Smart.
So it has like a common intermediate level.
Yeah. Okay. Yeah, sounds smart. I'm always wondering if it can be very optimized that way, but of course it depends on how much information you still have at the intermediate language.
Yeah, sure. And I don't know the details or how it's all done. It's just seems like a decent idea.
Okay. And you use your tool chain, or what did you test on Linux, right?
Yeah, on Linux.
Huh. Okay, and it's all documented? Everything is documented? Is everything documented, and there are examples and so on?
Yeah, there are plenty of examples online, and like not nice documents. It's quite user friendly, I think.
Okay. Now, I don't know if you want to talk about this. It's quite interesting because I never did anything with that. So, for example, how would you debug something like that? Do you have I don't know how you normally debug something like that at home, but...
Well, normally I use just debugging prints,
yeah,
I guess, or GDB or some debugger. And it's the same with Rust. You can use debugging prints, or you can use GDB.
Alright. And at what level do you debug? At source level? At Rust source level?
I haven't tried it that much.
Okay.
I ran it in debugger. I used debugger to flash the board, but not for debugging.
Okay. Now, to be honest, when I'm here at home doing something for a hobby project, I never debug anything. I mean, I do it like you debug printfs or toggle a I/O signal or something like that when something happens, so I can view it on the scope. But at work, I use some debuggers also for. I'm sure you did as well. I'm sure you do it. You now do as well, but that's much fancier. But I never do that here. It's not. Maybe I should.
But debuggers are. Well, I've used at least GDB. I've used it quite a bit on embedded, but it's often it doesn't help much. Often the issue will be related to timing somehow, and then debugging will just screw up all that.
Yeah. Sure. What I did on the I use Atmel chips a lot, and I guess there's other chips with similar instructions. So you have a one cycle or two cycles or one instruction cycle instruction, a very short instruction, let's say that sets a bit in I/O port, or clears a bit in I/O port. So, or actually sets a bit in I/O port if a flag is set or something like that. So set bit or skip or something like that. So I use that sometimes to include in, let's say, production code or the ready code to runtime enable an I/O signal when an event happens, and you can see it on the scope. So that's what I did, at least for one project, and it works very well. So you have that's the level of debugging that I do, printfs and that kind of stuff. Yeah, just looking at signals, right?
Yeah, so that's a good idea.
Yeah, because it costs nothing. It costs one instruction if you don't use it. So.
Yeah, that's really nothing, and it's. I have used it, but not in the way you. I mean, I've used it just as a trigger for oscilloscope when I wanted to look at some, I don't know, I2C traces.
Okay. Actually, do you? This is not. Yeah, this is going a bit off the track, I guess. But do you? I don't think you watch a lot of YouTube, but do you know Mike's Electric Stuff YouTube channel? So Mike Harrison.
Is that the Australian guy?
No. That's an English guy, Mike Harrison. He does a lot of the FPGA stuff and low-level stuff. It's quite interesting. And that was one idea I thought was quite smart. If you have a hardware UART or hardware SPI channel that you don't use on a chip, you can simply, instead of toggling an I/O pin when an event happens in production code, you can send a byte to an SPI register that shifts it out in hardware in its own time, let's say that. So instead of one digital yes/no indicator when an event happens, you actually have a value. So for example, a counter or something like that, or a delay. You can send a delay or counter or some information, you can send it out, and you can look at on the scope and you know exactly. I mean, it's you know exactly when an event happens. Plus, you have some extra information because most scopes can do decoding now, so that works quite nice. I thought it was quite smart.
So you're still using a scope.
You're using the scope for the real time stuff because the time that you write the register and the first bit is shifted out is known, or at least limited, and plus you have an extra byte of information, so it's quite nice.
Well, yeah, that's a good
Smart,
idea.
Right? Yeah.
Mm-hmm.
So
and it's still very cheap.
Yeah, extremely cheap.
It'll just be a few cycles,
yeah.
and then that's good.
In hardware, and if you do it in the UART, it only costs one pin. You don't. Yeah, maybe some other stuff. I don't know if I think we talked about it. I don't know, do you have timer or not?
Yeah, I do.
Yeah, not hours, but a little bit. So.
Yeah, not hours of time. I would be bored.
Right. So I think we talked some time ago about coroutines, or very lightweight cooperative tasks, or C constructs that allow for very lightweight cooperative tasks. So and, I'm quite happy with that. I use that a lot. Actually, there's projects when I use.
Yeah, you do quite a bit of that.
That's super. That's the one thing that makes life easy here. So in every little project, if there's stuff that happens asynchronous, or how do you call it, asynchronously, asynchronous. So I use that, or if I have a state machine, or if I have I have to wait for events, mainly state machines. Yeah, so we go to every state machine using that, and then they communicate with signal or flags. So you set the flag in one task, quote unquote, and you consume it in another task. It's not the fastest, but it's not very slow, because it's basically one jump, because what I use here is the GCC, the C and GCC, and it does computed go-tos, which is you can take the address of a label and store it in a variable, and then jump to that, go to that label, basically, and it's just one jump, one indirect jump, so it's quite fast.
Yeah, I believe it is, and I mean, you mentioned that, and I've looked then into it. I think every few years I get this from you, and then I look into it, go quite deep into details, try to understand it all, and I think then I forget about it in a few weeks.
Yeah, it's easy to make a mistake. It's easy to make for example, a task, quote unquote, that hangs, or a task that makes a little mistake. So it helps me quite a lot. So I think at one time I made a piece of software for. It was not a real elevator. It was like a play elevator, mock-up elevator control, and that sound, and like a display control, and like a pretend elevator that goes up and down, and you have the number that you see above the door would increase and decrease, and the motor would spin up, and so on, and it was all little tasks, and it was quite well, that was okay. It's not real time at all, but
it's not. So it's like a state machine, if I remember correctly.
Yeah, like 20 state machines simultaneously. That's right.
Yeah.
You have one big loop.
So for an elevator like that, it's getting quite complex.
Yeah, but you can do everything in isolation. You communicate with you can communicate with signals. So state machines, that's easy to make. And you would have one big loop that runs all the tasks, let's say that, round robin, and then the task can do something or wait for something. Anyway, that was my little thing. So maybe I post some example code or something like that in the show notes if I'm not too lazy.
Yeah, you should.
Yeah. Also, if you send me some, or if I can find the Rust stuff, I can also put it in the show notes if you want.
Yeah, sure.
Yeah. So if you,
I'll dig up some links.
Thank you very much. So if you still do a lot of C, right?
Yeah, I mean, I don't write as much C as I read. Yeah. I read plenty of C.
Right. So would you ever, do you see people using Rust now in production, or around you, or for actual projects instead of playing?
Around me, as in at work, not really. But that said, Rust is being used in Firefox.
Hmm.
I mean,
Well,
parts of Firefox are in Rust.
Hmm.
So that's like a large project
right.
where that many people know and that uses Rust.
Mm-mm.
I think some people got quite upset recently because I think they stopped shipping Firefox for some architectures because Rust wasn't supported, or well, LLVM wasn't supported on those architectures.
Mm-mm. Oh, right. Yeah.
Yeah.
Yeah, but I don't know. It's probably, I don't know if it's a big deal or not usually, or I don't know usually, but I can imagine people start pretending violently when their obsolete architecture is no longer supported, although it's been end of life by the manufacturer itself for 30 years or something like that. So, you know what I mean? So
Yeah, I know. The Linux kernel, for example, they've been removing quite a few architecture in the last few years.
Like what? Alpha or something like that?
No, like some of the less known.
Okay.
I think some of them were like it didn't compile for a few years, and it's like, oh yeah, why not just remove it?
It's just that it only looks good on paper, I guess, if you have a long list of architecture. But if you actually want it, I understand. If you actually want to do something like that, the maintainer is dead, or the maintainer is not maintaining it anymore and doesn't compile, and it's just it doesn't work. It's just ballast. It doesn't work anymore.
Yeah, just
that code.
Yeah, sometimes it's so nice to see patches that remove code.
Yeah. So that was that. Thanks for your effort, appreciate it a lot. You talked about coroutines, using coroutines in C code, and I'll probably paste an example in the show notes of coroutines used with GCC, but also you can use it from assembly language. I also did that, so I'll paste a code snippet where coroutines are used in assembly. And I guess basically any language that uses some form of computed go-tos, or computed go-tos, can use coroutines or something like that. Last time I talked about a VGA generator board with 4 VGA outputs and pattern data from memory or from microchip, a microcontroller, memory, or from SD card. Now I put another one of these boards at the Awesome Space place. Also made a little video. It's not very clear, but so sue me. And also, while I was there, I repaired a monitor. And calling this a repair would be a little bit exaggerated. What I did was open it up and turn a pot meter for the brightness or the contrast or something like that. I think only brightness, and that was it. Now, to be honest, I didn't know where to start. Some other guy who happened to be there, I was talking to, he had been working in TV repair for a long time, so he just said, oh, that's this problem. You see horizontal or vertical retrace lines rather, and so you have to turn the brightness a little bit down. So there's 2 pot meters on the flyback transformer, but if he hadn't told me, or I hadn't asked someone else, a friend of mine also told me there are usually 2 pot meters on the flyback transformer, but if nobody told me, I would probably just open it up and turn the few pot meters and probably see that it didn't have the intended result and then give up or something like that. So what did we learn? Talk to other people. So and that's probably pretty much it. There's 2 upcoming events. There's a Retro Challenge 2019/03. That's March 2019. And the registration page is up, so if you're interested in doing anything retro related or anything electronics or software or technology or old school or microcontroller related in the spirit of retro stuff, then give it a try. It's a fun competition. Hopefully it can help a little bit in the judging, or not the judging, but the summarizing again, reading all the entrance pages, and that should be a lot of fun. Furthermore, the 23rd and 24th March, there's a Maker Fair in Dortmund, in Germany again. And I think I'll go there, because it's 1 hour drive from where I am. It's an excellent location. I like that, even if there was no Maker Fair, that location is enough to just go there for a visit. It's work and job-related museum, so you have a lot of technology and a lot of job-related stuff there. So I talked about it before, I think, so I won't do it again, but it's Excellent location. I'll put links to both of these events in the show notes. And another upcoming event is the HCC Retro Division meeting in Bilthoven in the Netherlands. It's the 16th March and it takes place all day, so it should be fun. I'm going there and maybe report back a little bit about what happened there. So that was pretty much it. I'll hope there will be more co-hosted episodes. We'll see how this turns out. So if you like it or not, let me know. You can send email to the email address shown on the podcast.cba.si page as usual. And you can be the first writing in. So let's say that. So that was all for now. For more information, links and previous episodes, visit podcast.cba.si. Stay tuned, thanks for listening and goodbye.